Hello, let's start with our today's DSA journey with this amazing DSA visualizer by dsa.chaicode.com. Use this link to get a 7-day free trial. Okay, so let's start with our today's topic, and today is variable size window. So still now we are using the window size as constant, that we fixed our size as k. So this is our window. We only take k size, but now in the variable size we can expand or reduce the size of the window as it stays here, the expand, repair and record template. So we can increase the size, we can decrease the size according to the question. Obviously we can increase the size, decrease the size, and try to match the answer. So this visualization is very useful. Like, see, we are taking sum less than 8. Our target is to get sum less than 8. This is just a concept. We will go into a question after that. So we just take one L and one R. We have 4 as sum, and it has size less, the value or the total sum less than 8, and the size is 1. Now we increase our pointer, size is 6, size is 2, and the value is 6, 8. So consider this, it's 7, the value is 7, and the total sum is 7 and the size is 3. Similarly, if we increase 8, but now we cannot increase because it goes beyond 8 and we need sum that is less than or equal to 8, but the length should be maximum, so we can increase the L. So let's see here, we are just increasing our window from the starting, from 1, then 2, then 3, then 4. Then when we go 5, we don't match with the condition, so we just shrink our window. In the similar way we are doing this, you can clearly see in this visualization that here we are taking, every time we increase the window or decrease the window. So this concept is called variable size window. Okay, let's do a question using it, and the question is longest substring without repeat. Given a string, find the length of the longest contiguous substring that contain no repeated characters. As simple as that. So this is a string. We are given this string. So we have to find a substring which doesn't contain any duplicate element. A substring can be this P and W. A substring can be this WKE, but we cannot take WKEW because W here and W here is equal. So the largest is WKE. How we found it? We take a substring. We just take a substring, a part of the string. Also, every character inside this substring is unique. No duplicate character inside this substring. This is our condition. As simple as that. We have to take a substring and the substring should contain no duplicate character. So how could it do this? We can use a brute force approach where we are using two loops to check if we got any substring or not. Okay, so how? So let me remove this. So this is our string. What if in a position, suppose in a position I, we are taking pointers, in a position I would starting at here. So from this position till the end, from this position till the end, if we found a substring that is all unique characters, how could we found that? So we are using two loops. One loop started from I here, another loop j. J is also started from I. So we increase our j. And now in between I and j, also include the I and j. In between I and j, does any duplicate element present? No. Increase the j. In between I and j, is there duplicate element present? Yes. W is 2 times here. So W is here. Also W is here. So 2 times W. So we cannot take this. So for we just take this portion as a string. Okay. So when we reach a position, we increase our pointer I. Put a j here. Now put a j here. Is all character unique? No. 2W are present. So increase the I. And first start j with here. Then increase the j. All values are unique? Yes. All values are unique? Yes. All values are unique? No. Increase it. Increase it. All values are unique? Yes. All values are unique? Yes. So what is the largest thing? It is nothing but this one, or you can say this one, because we need to answer the size, and the size is 3 in both of the cases. But how? Let's suppose this is a string. But how could we actually ensure every element is a unique element? We can use a set, because set stored only unique element. So we can use a set, and every time we increase this j, we just check if the k is already in the set. No. E is already in the set. No. W is already in the set. Yes. So calculate the length till here and increase the I. Increase the I. Increase the I. So this is our approach. So okay. So I is at the starting here. J also at the starting here. Increase the j. The length is 2. Increase the j. We got a duplicate. Two w's are there. So duplicate. So take the maximum length till now. Increase the I. Put j here. Calculate length. It w. So we still the best is 2. Increase the I. Start with j. Increase the j. Increase the j. Any duplicate value present till now? No. Here. Duplicate value present? Yes. Okay. So increase it. Any duplicate value present? No. No. Any duplicate value present? No. Okay. So the best answer is WKE. The length is 3. We have to at the end in return the length and nothing else. So let's write down the pseudocode. We are taking a function. The function takes a string is, and let's take a max length. Initialize it with 0. Now a for loop for I starting from 0 to n minus 1. We take every element. We take every element of the array. Okay. Now for every loop we have to initialize a set. Why set here? Because set should include all the unique elements between I and j, not the whole array. Between I and j. Also include I and j. In between I and j we have to take. So let's take scene, or let's take it as scene. A empty set. An empty set is nothing but an empty set. So take another loop j. It always start from I, because we cannot take anything in the lower than I or the left side of I. So starting from I till n minus 1, if s of j, if the character in set scene, if it's present in the set, then on the spot break it. If it not seen, not in scene, or it, so add it to the scene. sin dot add or insert s of j. So after that, calculate the maximum answer. Calculate the maximum answer, which is here is maximum length, is become max length and j minus I, j minus I, and return max length. So now just evaluate it. Okay, we nailed it. Let's go to the question and write down the code here. So first write down the pseudo code here, and just for simplicity we just make it readable. So first take the size, which is nothing but take the size of the s dot size, s dot size. Then take a answer which is max length, the maximum length we can obtain. So take a for loop for int I equal to 0, I less than n, I plus plus, and inside this loop create a set which takes a character, set of characters, because we are storing character to check unique character or not. So it, the set will become character type. So now write the second loop which is j starting from I, j less than n, j plus plus till the last index. Check if st dot find s of j not equal to st dot end. It means we have found the element before the set ends, and it's clearly says that the element, the character s of j is already present in the set. For this reason, break the loop. Simple break the loop. Now, if it's not present in the set, add to the set. So st dot insert s of j. Just add it to the set, and after the loop, either break or either reaching the last point, just calculate the max length, which is nothing but max of max length comma j minus I, and return max length. Okay, yes, so we are using the identifier here, but when the loops ends, we cannot have the value of j. We don't have the value of j if the loops ends. So we can use one trick here. Just put it here and initialize the j at the starting, and in the for loop just use a semicolon. It doesn't give us any error. Actually it doesn't give us any error. Actually initialize it here. We can use a while loop also here, but a for loop is good. Just initialization step will go here in the top, and this semicolon just ensure that we are taking only condition and the increment or decrement. So the initialization is goes beyond and it doesn't give us any error. We just take it just to calculate this value, because j is changing every time. We need the j value correct place. Either we just take a variable, it works, although it is in last place, but it works. So why we are taking j, we can easily take a j here, like at the end we just put the j value into the index end index, and just at the end just put the end here and just do it. But in this method also it works. So it is a big of n square solution. We just take a set of character set, take the whole character, big of character set also. So n square time character set. So now a better approach, which is a sliding window approach. Let's see this. So in this case, we are using two loops. Like we are using a pointer here, then a pointer, then this pointer here. Every time we reach, we start it. We start the loop. Rather, if we take a window, although the window size is not specified, but if we take a window, it should work. It should work if we take a window. So how could I take a window? So when we hit a duplicate, we don't need to start from I plus 1. We can keep the window non-empty, just advance left side until the duplicate is removed. So let's suppose I is here, J is here. We have encountered a duplicate here, which is a W. So we have to increase our left pointer or I pointer till we remove the W, which is a duplicate. So P here, okay, W here, duplicate, till A here. So it goes the I pointer here. Still it stop. We have to ensure that the duplicate should be removed. We can use a set here. Obviously we are using a set here. But we have to ensure that we have we shrink the window until the element removes. The duplicate element removes. Okay. So simply L is here. Take a set which is seen. We take it as here as seen, which is a null set. It is a null set. R is here. We just take the size. Any duplicate? No. Any duplicate? Yes. When we encounter a duplicate, we just increase the L. We just increase our left pointer so that we get still a duplicate. We just increase our L pointer or the left pointer till we reach a point where the duplicate element removed. The duplicate element removed. There is only one W in the set. We just removing the P and W both. Now increase the R. Increase the R. We are taking the best window size possible. Increase the R. We got the W. We got the duplicate W. So for the duplicate, just increase the L till the duplicate is removed. We already remove it and we got the answer. Okay. So this is our sliding window approach. So write down the code. It is nothing but function. It will take a S, take max length, which is our final answer starting from 0, and L, which is starting from 0. Set, take an empty set, take an empty set for R starting from 0 to n minus 1 till the last index from the start, and while S of R in set till it present in the set, till the element present in the set, we have to do every time set dot remove. Like we have to remove the element which is at the left pointer. At the left, we just increase our left pointer every time. Why? Just to ensure that the duplicate element removed. Okay. And if no duplicate, then just add the value to the set. Add the value to the set. And every time calculate the max length. Every time we are calculating the max length so that we don't miss the maximum length, which is nothing but R minus L plus 1. So return max length. Let's evaluate it. Okay, we did it. But one thing can arrive, that here we are taking r minus l plus 1, here we are taking j minus 1. If we consider it I or j or r and l, it should be r minus l. Why? Because when we go to the for loop, every time when we reach the index n minus 1, when we reach the index n minus 1, the j loop at n minus 1, this index, suppose this index, so j at n minus 1, we performed all our operation here, and after performing all operation we just increase our j, so j goes beyond the loop, and now j point to n, not n minus 1, n. We are starting our string with 0 1 2 3 4 5, but now currently j is pointing towards 6. For that reason we are not taking plus 1 here, because when j at number 6, so again the for loop start after j plus plus, again the for loop start, and j less than n, if j less than n, again the for loop start and come and check this condition, and this condition fails, and the for loop stops and the pointer come here in this position, in this position the j pointer comes here, or the loop breaks and goes to the next, but the value of j is already 6. Okay, and for this case we are ensuring the value never get out of n minus 1, although it get out of n minus 1, but the max length we are calculating inside the loop, so the maximum length we can calculate till n minus 1, till this 5. So consider, so if we consider this as a element which is length is 3, so 5 minus 3 is 2. On the other hand, 6 minus 3 is 3. So 5 minus 3 plus 1, we have to do a plus 1 here, just to ensure that we are getting a maximum length. For that reason here r minus l plus 1, and actually here j minus I or r minus l, because of the pointers. Copy this, paste it here. Okay, let's uh, inside this loop, inside this loop. Okay, this should be outside. So first take the size, which is in nothing but s dot size. Now take a maximum length, which is nothing but our answer at the end, and take a length which is nothing but 0, and take a set which take char type st. Now for r, int r, it's starting from 0 till n, till n we just use a simple loop while st dot find s of r is not equal to st dot n. This means we found the element or the character s of r in the set. So remove. How to remove? So st dot erase s of r. It just remove the element from the set. Then just not s of r. It should be s of l. We have to remove from the start, so that we can remove the duplicate element which we actually encountered previously. If it's not, then add the element which is nothing but set dot insert s of r, and calculate the maximum length, which is nothing but max of max length and r minus l plus 1, and at the end return max length. It's work. Let's submit it. Okay, we submit this. So in this take we are actually looping only one time. This is only found, this loop is actually encountered when we found the element into the set, and into the C++ STL the set founding take big O of one time. So the whole program time complexity will become big O of n, and space complexity become big O of character set or the set size, because we are using a set here. Okay, so now a optimized approach where we are using a map, not a set. So in this approach, instead of removing one character at a time from scene or the set, remember the last index where each character appears. When we hit a duplicate, jump L past index in a single step. So when we actually encounter a duplicate, we just don't remove one element, one element, one element, one element. We just take the element and put it into the element where the last element encounter, which is a duplicate. So let's say, so L at the starting, R is also at the starting. Does we see P ever in the map? No. Then increase it. Are we see W in the map? We are using a map to store value and index. Are we encounter W previously here? No. Increase it. Are we encounter W here? Yes, we encounter W. Previously in the map the W is present. So the L towards this element. L should be point the element where duplicate arise. So duplicate arise at the point when R at 2. R at 2. R at 2. This R at 2 and we encounter a duplicate. So pick, take the L and put it into the R. Why? Why take the L and put it into the R? Because we just calculate the size of this window from L till R minus 1. So we put L to R where the duplicate arrives to calculate the new window. Here we are using a space, but also we are minimizing the minimizing our search space using we are erase one element at a time, every time one element at a time, but in this case we are just jumping towards the portion. Then again take it, take it, take it, take it. We just got a element which is better and bigger, and whenever we reach the last index, we just increase the point. Just increase the point when the duplicate arises. Okay, this is our approach. So let's just write the pseudocode it. So the function is taking a s here, take a max length which is nothing but the answer, a L which is nothing but the starting point, a map which is nothing but an empty map which take value and index, value and index. So for r starting from 0 to n minus 1, r starting from 0 to n minus 1, if the element which is nothing but s of r, the character in map actually is present in the map, and map of s of r is greater than equal to L. It means the element already present in the map and the current index of R is actually greater than L. And we are increasing and we are encountering a W. For this reason, just increase the point of L as map of S of R. We are encountered W here or duplicate here. So it goes beyond that. one index beyond that, and if it is not present, then include it include it include the index into the position. Include the index into the position. We are actually taking indexes here, not increase the value. So after that, just put the max length here, nothing but our answer, which is nothing but max of max length and odd minus l plus 1, and return max length. Okay, just run it and check it. Okay, it optimized. Let's write down the code here. So this is our code, just to ensure everything is online. So first take the size, which is nothing but is dot size. Then take a starting pointer, which is left, and so take a map, which is unordered map, which takes character and integer of map, nothing but value and the index of the element. So start it from r, start it from 0 to the till the last index. If mp dot find s of r, if mp dot find s of r not equal to mp dot end, so it means that we are actually getting a duplicate. Also, mp of s of r is greater equal to l. So actually we are in a position where l is lower and r is maximum. So in this case, just put the value of l as map of s of r plus 1, and here also map of s of r. If its value is not present in the map, just put the value here and calculate the maximum length. We are not taking max length here, just nothing but maximum length as 0. Max length is max of max length and r minus l plus 1. Similar is. So at the end, return max length. Let's run it and check it's work or not. Yes, it's work. 3 millisecond. Very fast. Map is faster because in this map we are not just removing one element at a time like set. We are just jumping towards the R or the duplicate where the occurred the duplicate into the R, and just go to the next index of the duplicate and get it. So it takes big of in time, and we are taking a space. We are actually using a map which is a big of character set. This character, then all character we stored in this map. So time complexity is big of n, space complexity is big of character set or the size of the map, because we are storing it value and index. So this is the question, longest substring without repeats. Using this visualizer you can easily understand concepts. Go use this visualizer, use this link to get a 7-day free trial. Go use this link to get a 7-day free trial. Thank you very much.